Okay, so in the previous lecture I showed you a little bit how to use Git in a simple case. So I showed you how you commit and how you look at the history of files, for example. So what I would like to show you in this lecture is how does Git fit into, let's say, the workflow that we use in real practice. So let's say if you have a project that you work on with others, or maybe just something that you thought was for yourself, but that one of your colleagues would like to use as well. So Git is by itself not a terribly useful tool. What is missing is that you need to have some place on the internet, for example, where you can store your Git repositories and where you can, let's say, move patches between your local Git repository and then the one online that other people can access as well. So I didn't show you this because setting this up yourself turns out to be actually a little bit complicated. But there is a web service today that is called GitHub that makes these things really easy. It allows you to create repositories for your own projects that you can share with others, or for a fee you can also make them only for yourself. And so I would like to show you a little bit how we work with Git and GitHub in practice for open source projects or for any kind of big software project where you have a central repository somehow. And let's say, what is the workflow with which we work? So this is lecture 32.8, Git and GitHub in practice. And let me talk really quickly about GitHub. So GitHub is a web service or an internet hosting service for open source projects, but also for other projects. If you pay for it, then you can make them closed. So not everybody can see every project. Basically, the way you can think about it is it has a central repository for every project. And then it has individual people's repositories of these projects. We call them forks. So you will see in a second how that works. So in essence, think about it like this. So there is a central repository for every project, and then every individual has a copy of that repository, or well, a copy that was made at one particular point in time. And then GitHub, so in addition to just offering the basic facilities to let's say serve data and to store repositories, it also facilitates the movement of patches through a web interface, and that turns out to be really, really useful. So the website at which this is stored is called GitHub. I should say I'm not associated with github.com. I'm not associated with GitHub. It just happens to be the tool that basically everybody uses today to develop open source software, or for many other things as well. So the typical workflow works like this. So somebody has created a central repository for a particular project. So each one of these blue ellipses here are going to be a repository, or let's say the files that correspond to it. So let's say there's a deal.II repository somewhere. And then let's say if I want to work on deal.II, then what I would do is I would create what we call a fork. So a fork is essentially my own clone of the project repository. So at the time when I create this fork, it's going to be identical, but over time they might diverge. So other people might commit changes into the central repository that I don't currently have, or maybe I upload changes that I have made that are not in the central repository yet. So one of the things that I will have to talk about is how do we facilitate the movement of patches. So both of these, the central repository and the fork, reside on servers provided by GitHub. Okay. Now, if I want to work with this, then I first have to get a local clone. So a local clone sits on my own hard drive, or my SSD, or my USB stick. Okay. So it is a local copy, independent of these web-hosted repositories here. Okay. And this one is something that I can work with locally without internet connectivity, so I can work on it on a plane or at the airport. From my local clone, so that's a Git repository, okay, I'm going to check out a working copy. So that is the set of files that I can modify and edit, okay. And every time I make modifications and I have verified that they're correct, I will then put them will commit them into my local clone. Before I get there, I should say that so when you clone a repository, so when you call git clone, it doesn't just create a copy, a local copy of that repository, but it also automatically creates a working copy, so the set of files that we can work with. So I don't have to do this here by hand. I can do a clone by giving specific flags to git clone that only create the repository, but the default is to already create a working copy. So then I make local changes. I go back and forth. I edit files. I compile them. I test them. I verify that they're correct. And when I'm happy with those, then I will commit them to the local clone. So all of these things happen only on my own file system, on my hard drive. And then, of course, it becomes interesting only if I move these local changes here actually somewhere online to my clone, for example, on GitHub. Okay, that has different purposes. First, of course, if my hard drive crashes, then I'm in trouble if I have not moved them to some other place. So moving them from my local copy to the GitHub clone is a form of backup. But also, of course, I might want other people to see these patches, or maybe I want to eventually propagate to the central repository. So the operation that moves local changes into my GitHub cloned repository is called a push operation. And then the next step would be that I, well, if I can, let's say if I have write access to the central repository, I can just push changes from here into the central repository, or if I do not have write access, then I would just issue something that is called a pull request. So a pull request is essentially a ticket that I create in an online system that says, here are a few changes that I have made that could be merged into the central repository, and it sends an email to the developers of that project, and then they can go online and they can look at the patch, they can make suggestions of how maybe to improve it, and if they're happy with it, they just click a button, and the patches that I have pushed to my clone will then automatically be pushed into the project repository, or pulled, or whichever way you want to see it. So if I suppose if a developer hits the button, then that corresponds to a pull operation, but conceptually it's the same. Okay, so in practice, when you do this, there is of course a delay between creating a pull request and getting it accepted. So there's a time when the state of my repository is not the same as the state over here, because the main developers have not looked at my pull request and have not approved it. And so one of the things that turns out to be convenient in practice is if the master branch of the cloned repository on GitHub and my local clone happen to be always basically in sync with the master project repository here. So the master branch I want to keep in sync, and what that means is that when we do development, we do almost all of the development on branches. So we create a local branch, we call this a feature branch. In my local repository, I do development and commit one or multiple changes, and I push the whole branch from my local copy to my GitHub clone, and then I create a pull request for the changes between the base of the branch that I have just pushed and the tip of the branch. So that would indicate all of the commits that I have made on my branch are the ones that will be moved into the main development source. So to make this less abstract, let me go through an example of this workflow. So what I've done is, or what I have not done, but what I want to do is I want to go to GitHub, okay, and I will go to a repository that is developed primarily by one of my colleagues, Timo Heister. So I'm going to go to his GitHub account. The repository that I'm looking for is called Burnman. So this is the website that represents the Burnman repository, let's say his local clone, sorry, his GitHub clone of the Burnman, and it says forked from. So here is the central repository. Okay, so geodynamics Burnman. So what I first need to do is I need to create my own fork. So I'm clicking on fork, and where should we fork this repository? I want it to be forked into my own GitHub account. Okay, so that's going to take a little while. Okay, so here we are, and there is a web address over here. So this is now my clone of the Burnman repository. Here is the HTML address of it, and so let me now create a local clone of this. So I'm going to go to math 676. I'm going to go into creating a temporary directory. So then I'm going to say git clone and this address. Okay, so github.com bangerth_burnman.git. So let's see. Okay, so it has cloned and already created a working copy. So if I go into this directory here, you will see these are all of the files that it has created. These are the files that correspond to this project. And if I say ls-la, you will find that there is also a directory .git and 2 additional files. So this is where the actual local clone of the repository is stored. These are directories that we don't need to worry about. So they're prefixed with a dot, and that means that if I just say ls-l, they don't show up. So if I knew anything about this project here, I would start developing, right? So there's a feature that I want. I don't know what the feature would be. As a matter of fact, I don't actually know very much about Burnman. I know what it does, but I don't actually know the source code. But of course, when I looked through this yesterday and I tried to prepare for giving this lecture, I found something that's worth fixing. So there is a file constants.py, and as it always happens, there is a place where there is a misspelling. The name is not Avogadro, but it is actually Avogadro, and they got it right in the next line. So all I'm doing here is a Python file. All I'm doing is I'm going to change the typo. Okay, so that is going to be my example of, let's say, some development. Okay, so I'm going to save it. I'm going to get out of here. So if I say git status, what it's going to show me is that, let me make this a little bit bigger. Let me do this again. So it's going to show me that I'm on the master branch, okay, and that there is a file that has been modified. So in order to create a commit, like I said, I would like to create a branch first, and I would like to commit on the branch, and then I will want to move the whole branch up to my clone, and then from there through pull request to the global repository. So I'm going to say git branch, and I'm going to name the branch fix typo. Okay. If I say git status, I'm still on master, but the branch now exists, so I can say git checkout fix typo. Okay, so if I say git status now, it shows that I'm on this branch now here. Okay, and now I can say git commit -m fix a typo and the name of the file. Okay, so now it got committed. You see the 7 first digits of the 40-character hash of the commit. Okay, so if I say git status, it says nothing to commit. There's nothing left that hasn't been committed yet. And if I look at the program that shows me the version history of my repository, of my local repository, right? It's all just happening on my own hard drive here. So git k shows me the local history. So you can see how there were all of these people who had done development on a branch, and then it got merged. Okay, somebody else fixes something and it got merged into mainline. Well, so here's the master. Here's my branch fix typo. Okay, so this is the commit that I just did, and you see the differences down here. So git k is a really useful tool to see how a repository has evolved, what kind of changes have been made, and so on and so forth. So you see that there are a number of people over here who have contributed to this repository, and you see how they always worked. They created a branch, and made certain changes, and then the branch was merged back into mainline. Okay, so I have made my change. Now the next step is this exists only on my local hard drive, so I need to somehow get this upstream to the repository from which I cloned my local clone. So the way you do this is you say git push origin and then the name of the branch. So fix typo. Let's see if this works. So I need to remember my username. That is Bangerth. Let's see if this works. Okay, so there are some warning messages, but I do believe that it actually worked. So it copied my local fixed typo branch to a fixed typo branch in this repository. That's my clone, okay, and that branch did not exist, so it rightfully tells me that there's a new branch. And now let me go back to my web browser where I had the Burnman repository, and lo and behold, so GitHub is actually pretty cool. It shows me that I have created a branch, and so I can click on this. Okay, what you will see is that on this branch, I can look at the commits. Okay, and the latest commit on this branch is fix a typo. Right, that's the one that I just committed. So what I want to do with this branch is that I want to create a pull request. So a pull request is, like I said, a notification to the maintainers of that project, of the Burnman project, that they can move certain commits that I have made in my repository to the central repository. And I can do this by clicking here on compare and pull request. Okay, so that corresponds to my fixed typo branch. So it's going to show me all of the differences that I have made. Well, that happens to be only one in this case, but this might, of course, be dozens or hundreds of lines. And then up here, there is a place for me to give a one-line summary of what I did and a more extensive description. Okay, so in this case, I don't know. There's not very much for me to say for one character typo, but oftentimes you would say something like, I don't know, fix the algorithm in constraint matrix, and then down here would be a lengthy description that says what exactly it was wrong, how it manifested itself, what I did to fix it, and so on and so forth. So a typical text here would be, let's say, somewhere 6, 8, 10, 12 lines of code. So I'm going to create a pull request. Okay. And GitHub automatically takes me to the geodynamics Burnman. So that's the upstream repository. That's the place, the central repository. And what you see is that it created issue number 128. So apparently 127 times before, somebody else has created a pull request or a bug report or something. Okay. It says that it is open, and if I click over here on the list of pull requests, you will see that there are a few open pull requests that other people have opened, but that have not been dealt with. Okay, so there are some that one of the maintainers of the Burnman project will eventually have to get around to looking at, and then make a decision what should happen with it. So I'm not one of the maintainers of the Burnman repository, but I will show you how this looks like on the other side. So if I go to my GitHub account, then I can go from there to my repositories. So, for example, the deal.II repository. Okay, and so for this one, I am one of the maintainers. I have the right to accept pull requests. So if I go to pull requests, so there are a few. So there's one, for example, that my colleague Bruno Turksin, whose username is Rumbor here, created a few days ago. So if I click on this, okay, so this is the interface that I, as a maintainer of the project, get to see. So there's a conversation that we had. We discussed the issue. So you see that multiple people have contributed to the discussion. I can see also what kind of files were changed. So I'm not going to click on this because that's a long list of changes. Okay, but well, maybe I show you this for a simpler one. Let's take this one here, for example. Okay, so if I look at the files changed, then you get the diffs. Okay, the differences between the base of this person's branch and the tip of the branch. Okay, and in the conversation here, I can eventually go to, I can comment on this. So here I can't merge it automatically because apparently there are conflicts between this patch and the current version of the repository. But if I go back to the one by Bruno, that should work. So I could, if I wanted to, in addition to commenting, I can click on this merge pull request, which I'm not going to do here because we haven't settled the issue yet. But I could click on this, and then that would automatically take the one commit that he has put onto his branch and would merge them with the master branch in the central repository. So that's sort of the way we deal with Git and GitHub. This is the workflow with which we make, let's say, local commits, or let's say we create a local patch, we commit it locally, we push it to our clone that's on GitHub, and then we create a pull request so that the maintainers of a project can look it up. It's a really, so it sounds like a rather complicated process, but in reality, it's actually a very powerful tool. So if you think about how online communities organize themselves, that turns out to be a very efficient way how communities work together. So in the case of deal.II, there are several dozen people who have contributed patches this way. So to sum this up, I had a summary slide somewhere. No, maybe it has disappeared. Well, anyway, let me pull this up here. So to sum this up, that's right. There's one more issue that I wanted to say. So in my case, I do have write access to, let's say, the central deal.II repository. I could, in principle, directly clone to my hard drive from the central repository, and I could also push there because I'm one of the developers who have write access. In practice, that's a bad idea. It's too easy to accidentally commit something if you push directly to the central repository. And the other thing is, if I create a pull request, that invites other people to comment on my code. Now, as a developer, it turns out that you are at your best if you let other people comment on your code, and if you take that seriously. I think one of the things that we have learned when we moved to GitHub is that I have been programming for 25 years. I think I'm a fairly good programmer, but my code gets better if I let other people comment on it. So it's generally a good idea to have the central repository, your fork, and then your local clone, rather than just work with the central repository, at least if you work with other people. So to sum this up, the Git program and the GitHub website or service facilitate workflows that allow for what we call a decentralized software development. So everybody has their own forks and clones, and you can make whatever changes you want, both locally and to the one that you have to your forks. You can control which patches you want to flow to other repositories. So the things that I do on my local hard drive are things that nobody can see. The things that I push to my fork are things that others might be able to see if I make my fork public, but they don't become automatically part of the central repository. So in particular, for things that I'm not quite sure yet work or that are not quite done yet, I don't need to put them into the central repository yet. That has the advantage that, let's say, the threshold to contribution becomes much lower. I can work with a repository without having to have other people already see what I do. And that's the big advantage to this one central repository that we use with Subversion. In Subversion, you can also create branches, but all of the commits you make happen in the central repository where everybody can see it. So from the perspective of something that, let's say, as a community we do, Git and GitHub actually works really well. It's more complicated to deal with than Subversion. Subversion is a much simpler model, and it's definitely helpful if you understand how Subversion works, if you want to understand how Git and GitHub work. But from a practical perspective, GitHub is something that makes the interaction of communities a lot easier and a lot more professional. And I think that's one of the reasons why, over time, most of the projects have migrated to GitHub, or let's say some service like GitHub, or probably will at one point in the future. So that's the sort of things that I had to say about Git and GitHub. It requires a little bit of getting used to. It's something that we need to practice, but once you've done it a few times and you've worked with it for a couple of weeks, it becomes a quite natural thing to do, and it's also a lot of fun to work with this. So I think with this I'll close the lectures on version control. I want to implore you again, use version control. There is nothing that helps you more to write good software than version control, because it allows you to go back in time, it allows you to look at why a change was made. Version control really is your friend. Use it.